I'm just going to quickly go through some slides and talk about today's topic, which is serial communication and processing in P5. And then I'll show you some example code that you can just download and try and get running on your computer. And then you can tweak it and modify it and play around with it further based off of what I supply to you. So serial communication is, we've kind of played around with it a little bit already by getting serial information from like an analog input, like a potentiometer or knob or a photocell sensor or something like that. And then we use that information and output it to, so far, output it to like an LED to make an LED dim. But you can also use serial communication to communicate between your computer and the Arduino itself and vice versa. So when we're playing around with serial, we're playing around with ASCII characters that are being sent to and from the Arduino. So when we do serial.print, we are getting ASCII characters as the character. So it's printing like an A or 1 or 2 or B, etc. Or other values like that. We're going to be talking about this function, this method called serial.write, where we can write values from the Arduino to the computer and then use that to like change the size of a circle on a screen or change the color of a background or something on your screen. And that gets sent as a hexadecimal value, which is also ASCII. And then all of these are, if you go deeper into like computer code, ultimately all of this is converted into binary for the computer to understand and work with. So here's just an ASCII chart. This is showing you all the different characters and what they mean, and then also the value broken into HTML code, hexadecimal value, decimal value. So this is kind of a helpful chart to see, like, okay, we have an uppercase A and the hexadecimal value is 41 for that. And then like 1 hexadecimal value is 31. So that's kind of helpful for us to know when we're sending values to and from our computer to the Arduino and back and forth. So for today, all the examples that I'm going to show you are based off of this Arduino board setup. So why don't we take a minute, have you guys set this up so it's ready to go. It's basically just a knob, a potentiometer, that's connected to the Arduino on A0, and then an LED with a 220 ohm resistor, which is then connected to an output on 9. So let's take a couple minutes to get you guys set up with this, and then I'll move on. All right. So the first method that we're going to be playing around with is called serial.write. So .write is basically going to write a value that we're getting from the Arduino, from like in this case our knob or potentiometer. And then we can send that to another program called processing or P5 and apply that value to like the position of a square on the screen, or the size of a circle, or the color of the background, or anything like that. So we could take these values that we're getting from these analog components through the Arduino and then apply it to a digital environment like a game or an interactive, like, I don't know, animation or something like that. So everything here is very similar to what we had before. We had this, in setup, we have to do our serial.begin because we have to use serial, so we have to start it. And then in loop, we're just gonna take the value from the analog read, which is A0, and then send it to serial.write. We're going to put a little delay, like a 1 millisecond or 2 millisecond delay, because if it's sending data too quickly from the Arduino to the computer, then it could get like a little bogged down if it's going too fast. So it's always good to have like a very small delay in there to help that out. And then all the stuff that's commented out is just printing the values to the console, so we could see the numbers that we're getting. So there's lots of different platforms you can use to see just basically another version, another way of looking at like the serial monitor, like what we were doing before. So this is one, it's called CoolTerm, that I used to use, but it's it's really old, so I'm not sure if it actually still works or not, to be honest. And then when it comes to taking those values and applying it to something digital, we are going to be talking about using processing. But mainly in today's class, we're going to focus on, so here's the processing website. We're going to focus on p5.js, which is a version of processing, but it's built in JavaScript. And there's a web editor that we can use to program in, versus processing, which is built in Java. And it's an application that you have to download and use locally. So it's a little easier to use P5 these days. When it comes to serial, it's a little bit more challenging, but we'll figure it out together. So when it comes to taking the values that we're getting from the Arduino, from like the knob, and sending it to P5, we have to use another bit of a small application called P5 serial control, that basically allows you to look at all the ports that you have connected to your computer and identify the port that the Arduino is plugged into, and then get data being sent from that port to your computer and pass it into the P5 environment for us to use. I was having some issues with the latest version of this, so I'm going to share with you the download link to the version that I have, which is working with the code that I have, so that's what we're going to use today. I'll try and figure out why I'm having issues with the latest version of serial control, but for today, let's just use what I've been using. Let's stick to that. So all this is going to be new for most of you, unless you took like my creative coding class, but for P5, again, it's all JavaScript, so these are all JavaScript files that we're using. We have to use another one, it's called the serialport.js P5 library. And again, I don't want to go too deep into the like code and like line by line. I'm just going to give you some example code that you can use and like tweak and modify and play with. I mainly just wanted to get it working for you guys. And then if this is like a path that you want to go down and play around further, then I could help you out as an individual. But I just want to kind of get something working and then help out individuals who want to do this more. So to make this work with a web environment, do serial communication with a web environment, we're using something called OpenSockets, WebSockets, which again, I don't want to go too deep in because that's just going to be more confusing than helpful. But it's just a way for us to have like a stream of data being sent from the Arduino to the web browser, and then allowing us to update something in real time based off of that real-time data flow. And that's what the serial control application is helping us with. So I think it's probably best if we just kind of do this together. So let me switch screens real quick. So let's go ahead and go to the class website and go to week 7. And the first thing I want you to do is download this serial control application download. This is the version that I'm using that I know works. So if you click on that, it'll download the zipped version of the application that I'm using. So let's go ahead and do that. It might take like a minute or two to download it. And while you're doing that, if you scroll down under labs, so there's the serial write for Arduino, there's the version for processing, and then the version for P5 and WebSockets. If you click on that Git link, it'll take you to the Git repository for where all of my example code is for this particular session today. For anything, at least on the Mac, for anything that is like suspicious to that Mac, that is usually like an open source application that doesn't go through all the rigmarole that like Adobe goes through to get approved and whatnot. If you do like a right click or control click and then go to open, you can bypass all the issues there. So if you click on the Git link, that's for p5.js and WebSockets. This is all the example code that we're going to be working on today. Let's go ahead and open up the Arduino editor, and we can plug in our Arduino boards as well. And the first thing that I want to do is let's do a write to p5 project. So if you create a new sketch and then go back to that GitHub repository, and let's go to p5, I think read. Let's try that. Look at the Arduino read and then the Arduino code. Yeah, this is the right one. Then we can just copy that and paste it in here. And this is basically, again, just setting up serial to start. In our loop, we have a potentiometer, which is the knob variable, which is set equal to analog read. So we're reading the values we're getting from the knob at A0. Then we are remapping that value. Probably don't need to, but it's fine. We could remap this value to go between 0 and 1023 and change it to be 0 to 255. Then we're going to do serial.write, the value that we're getting after remapping it. And then the last thing is just we're adding a little delay of 1 millisecond at the end. So we're not sending the data too quickly for it to like get bogged down. So this is the Arduino code for the first example, which is basically going to be taking the value of the potentiometer, the knob, and sending that value to P5 to, and this example, we're just going to increase and decrease the size of a ellipse, a circle on the screen when we turn the knob. So let's just go ahead and upload that. Okay, and then I'm going to go to my desktop, find the serial control that you guys just downloaded. Again, I'm on a Mac, so I'm not sure if this is going to work on Windows for you or not. But if you haven't opened it yet, feel free to right-click on it and go to Open. And then this is what you should see. Something like this, anyway. So over here, it gives us like a description of what this is and how to use it. This is my IP address where I am. Yours will be different. So if it's not working on Windows, let's try and go to serial control, that link on the class website, and try and download the beta 1.2 for Windows. And maybe it'll work on your machine. Maybe it's just my machine that I'm having issues with for some reason. So let's hope that's the case. I was having issues with P5 and sending data to P5. So let's see if that works for you. If it does, then that's awesome. It's just something to do with my machine or my setup. So let's try for Windows people, let's try and download the latest version and see what happens. Okay, so if you're using the latest version, it's going to have a slightly different design, kind of look to it, but essentially it's going to be the same. So in the serial control window, yours might look different, will look different if you're using a newer version of it. And then here we have our ports. So I have like a port for my Bluetooth, a port for my AirPods, and my wife's AirPods that are for some reason called Chris. And then there's a third port that is plugged into my Arduino. So this is the name of the port that the Arduino is plugged into and where we want to be receiving our data from. I believe if you select the port here and select port and then open, it's opening that communication, and then you can enable the serial console. You can see the data flowing. So you should be able to see when you turn the potentiometer that the values are changing. So it's basically the same thing as a serial monitor that we were using in the Arduino interface. So we're getting the same values from that. So I'm just gonna close that for now. Can open it later. Okay. So we know that we're getting serial data into this serial controller, so that's working. So yeah, usually if it's not showing up, then unplugging it, plugging it back in again is good. Quitting and reopening might be a good thing to try. Okay, cool. The next thing that we're going to do is go to a new tab in Chrome, and we're going to go to p5.js.org. So p5.js has a web editor, which is great. We can start coding in the browser itself and have our serial controller send data to the browser window to basically modify any of the objects we have in our sketch, in our code. So if you go to the home page, there's a big button that says Start Creating with the P5 Editor. You click on that. Then you'll probably have to log in, create an account. So yeah, actually it'll probably show a screen like this, but at the top it should say login or sign up. If you don't have an account already, then go ahead and sign up and make an account. Then I'm just going to log in. So you can see that there's some similarities already when it comes to Arduino and P5. So with Arduino, we have a setup, right, that runs once. With P5, we have a function setup that runs once. And then with Arduino, we have a loop function that runs continuously. With P5, it's just called draw, but it acts the same way. It's just constantly running and looping through this code. So the setup is very similar to the Arduino code. So this should be fairly easy for you guys to wrap your head around. So yeah, so in P5, we have to create a canvas, which is just like a painter's canvas, basically. And that's going to be drawn in our preview window when we run the sketch. So create canvas is the function, and then we can pass in the width and height of the canvas size. And then in draw, right now we're just giving it a background, which is a color. If it's 1 value, it's going to be grayscale. If it's 3 values, it's going to be red, green, and blue, RGB. So if we run the sketch, then we have a 400 pixel by 400 pixel box over here, which is our canvas. And the background is this gray color. So we could change this. This is going to be a range between 0 and 255. So if we do 0 instead of 220, then it's going to be black. If we do 255, then it's going to be just white. So that's kind of like a very basic crash course into P5 and programming for it. So again, we're just going to copy and paste today, and then I'll kind of talk you through the code a little bit. If we go back to that Git page where we copied the Arduino code, and we go back to the read P5 read folder, then the sketch.js is a file that we need. So this is all of our P5 code. So if you go there and just copy this, go back to the editor and paste it here. I think we're going to get an error, but we'll talk about that in a second. If we run this code, then yeah, we get an error. So it says serial port is not a constructor. So the serial port doesn't exist because we need another library to use it in P5. So for P5, in the web editor, if you click on this little arrow on the left-hand side, it opens up your root directory. And if you took like Web Design 1, you know that websites always have an HTML file. They usually have a CSS file, and then they also have a JavaScript file. So these three files are kind of the languages of the web. We're mainly going to be using the sketch.js file for anything we do with P5. The only thing that we would want to do in HTML, in the index.html file, is add this serial port library. So if you go here, this is the P5 library. This is the P5 sound library, and then this is the CSS file. So we just need to link in the serial port library as well. So for that, if you go back to the class website, week 7, I put a link underneath this serial control application download called serial port library for p5.js. So if we click on that, it's going to go to another GitHub account. And then if we scroll down, we could see that there's a get started section. And the only thing that we really care about is this bit of code here. So this is the link to the serial port library that we need to have in our HTML file to be able to use it. And we can just copy and paste this bit of code, this JavaScript link here. So select that and do Command C for copy. Go back to the web editor, and then after the P5 library and before the CSS file, let's paste that in there. So now we have this link to the code for the serial port.js library for P5. So now that that's in there, then we should be able to run this sketch, this code, and it should work. So let's go back to the sketch.js file, run it, and open socket. Okay. I think for this we also need to select the port and the serial control window that our Arduino is plugged into, and then open that port. Let's see if this works. Hopefully it works. There we go. Cool. So now when I turn this knob, I'm passing the values that I'm getting from the knob into P5 and applying those values to the size of this circle, essentially. So as I turn the knob, the circle on the screen gets bigger and smaller. So I could walk through this real quick. So at the top we have a variable for our serial read, or serial object, essentially. That's part of the serial port library. Oh, sorry, it might not be working for you because your port is going to be called something different. So the port name is the name of the port that the Arduino is plugged into. So mine is dev/cu.usb modem 1411. Actually, no, that's wrong. So this is my port. I don't know why it actually worked. So that's basically sending data from the Arduino through the serial control panel here and into the P5 sketch that we just created. So yeah, so the port name has to be defined here. The variable R is going to be used down here for serial.read function, which is basically reading the values and converting it into a number that we're getting from the knob, the potentiometer. In our setup, we're just creating canvas we are creating this serial port object using the library that we just added. We're applying a method to this object called on, passing in the data and the serial events, which is like the callback for getting that data from the Arduino. And then in draw, which is again just a loop that we're looping through constantly and running through this code over and over again. We're drawing the background, which is black. We're applying a fill color, which is white, to this ellipse value. And the ellipse, you pass in an x and a y for the position. So that's width divided by 2, height divided by 2 is going to give us the center point of this canvas. So that's why the ellipse is in the center. And then for the width and height, we're just giving it the R value, which is the value we're getting from the knob when we turn it. There we go. So yeah, I think my potentiometer is just a little finicky sometimes. So that is sending data from the Arduino to processing and applying the value to a digital element on the screen. Obviously, you can think of how you can apply this to different things. Like if you wanted to make like an arcade game and build an arcade cabinet and take the values from the button presses and the toggle switches and all sorts of stuff and apply it to something digital on a screen. That's a great example of how you can use the serial communication with Arduino with a digital environment, like a gaming environment. So it's just like building your own PS5 controller or Xbox controller or something like that, and you're controlling the players on the screen. So the next example that we're going to copy and paste and talk about is going the other way. So we're going to write some data to the Arduino. So let's close this port. One thing that you have to keep in mind is that you can't have the serial port being used by multiple applications. So if this serial port is running, the serial controller is running, and you try to upload data to your Arduino board, then that's going to fail. So you have to close that port or close the application completely, and then you'll be able to upload your code to Arduino. So you can't do both at the same time. You have to do one and then the other. So for p5 write, let's go check out the Arduino code. I'm just going to copy this, go back to Arduino editor, and replace this. And basically what this is going to do is the LED that we have plugged in on pin 9, we are going to send data to the Arduino from P5. So we're going to go the opposite direction. So in P5, when we type H, the LED is going to turn on. When you type L, the LED is going to turn off. So let's go ahead and upload that code. Okay, so mine uploads successfully, which is good. Then let's go back to that Git and go back to the sketch.js file. So again, in p5 write, then sketch.js. We want this code. Go back to the p5.js web editor, and we can just replace it here. Okay, let's play. Something went wrong. Oh, okay. We also have to change the port to the port that you guys have on your machine at the top. Let's see if that works. So now when you run that sketch, if you hit capital H, then the LED should turn on. Hit capital L, then the LED should turn off. So now we're controlling the Arduino with keystrokes on our computer's keyboard. We're sending data to it anyway. So again, similar setup on P5. Create a variable for a serial. Create a variable for a port, which is this port name. In the setup, we have to create our canvas. We have to define our serial objects. We're setting up an error handling system for if there is an error for serial. We're opening the port with the port name. Here's our error handling function. And then in draw, we have just the background, the fill color, and then the text. And this is just text, so the person knows what to do and how to use it. And then we have a key pressed function at the end. So it's saying, okay, if you press key H, then send that key value to the Arduino. Press key L, capital L, then send that key value to the Arduino. And then Arduino knows that it's looking for an H or an L. If it sees an H being sent to it, then it's going to turn the LED on. If it sees an L being sent to it, then it's going to turn the LED off. So H, L, H, L, H, L. So we could look at the Arduino code here. So it says basically when I see an H, send high to the pin. When I see an L, send low to the pin 9, to the LED. Cool. H on, L off.
Does it have to be up?
Yeah, it has to be uppercase. Capital H, capital L. And obviously you could change that if you wanted to. So if you wanted it to be like a different letter or a lowercase letter, then you could change it here. And then also in the P5 editor too. So let's try that. So let's do lowercase b for on and lowercase a for off. Let's upload that to the Arduino first. If we get an error, then it probably means that the P5 sketch is still running and serial is being used already. And then in here we say, okay, then B and A instead of lowercase. Let's run that. Serial port. Okay, something went wrong with serial port is already open, so this probably won't work. So it's probably, let's try reloading this Arduino page. Okay, let's try it again. All right, let me close that, close this, and then reopen everything. Okay, then A, B. Okay, so now it works. So yeah, so there was an issue because one of the other applications was using serial when I was trying to use it in the P5 editor. So that was causing a conflict between those two. So now A and B work instead of H and L. So you can kind of like consider doing something like a, I don't know, a game on your computer that is like, has something to do with stoplights or something, and you have to hit it in a certain order on your keyboard to play the game, something like that. I don't know. But yeah, controlling these are serial, but we're kind of using it like digital, where we're just turning on and off an LED. You can obviously do something more complex, which we'll do in a second, but this is just kind of very basic on a key press, sending that key press to Arduino, and then Arduino is doing something, in this case, just turning on an LED. All right, one more example. So let's go back to the GitHub repo for P5, and we're gonna do analog write this time. So P5 analog write, click on that. Let's get the Arduino code first. Click on that Arduino analog write folder, and then the Arduino analog write.ino file. And we're gonna copy this. Actually, I just noticed the pin number is wrong, so we want to change that 6 to a 9 when we copy it in. So let's copy this, go back to the Arduino code, and let's just replace this. And make sure that you change that 6 to a 9, since we're plugged into port 9, not 6. And then we can just upload that code. And again, if you get an error message, it probably means that you're still running the P5 sketch, and which is using the port Let's go back to the GitHub repo. Go back to the p5.js folder, analog write, and then sketch.js in that analog write folder. And then we're going to copy and paste all this. So copy that, Command C, and then let's paste it, Command V, into our web editor. And then again, we have to go in and change the port to the port name that our Arduino is plugged into. So that could be COM3 or whatever, or it could be something like this. Okay, so let's see, let's try and run this first, see if it works. Cool. So what's going on here is that my cursor, my mouse, as I move it up and down in the canvas area, it's going to dim the LED, make it brighter, and then make it darker. So as I go down, it's going to get brighter. As I go up, it's going to get darker. So we're sending analog values essentially to the LED. So you can imagine using this for like building a computer-controlled robot or something, where you can control the servo motors, angles of like the arms and legs of the robot in like a digital web environment like this. So this could be like going up and down, can make it like walk forward or backward, going left to right, can make it like raise its hands or lower them. So this is a very simple example of changing value from the computer to the Arduino. If you go too fast, it kind of gets a little buggy though. So for this, the code is very similar. You have a variable here for out byte, which is the data being sent to the Arduino from P5. All this is the same. The error is the same. Error messaging is the same. The draw function is just a black background. Actually, we probably don't even need this fill because we're not applying it to anything. And then we have a function at the bottom, which is called mouse move. And we're applying the value and the position essentially of the cursor of the mouse when it's on the screen, on the canvas. And we're remapping that to be a value between 0 and 255, which is what an LED requires. And then we're doing a serial write to the Arduino, which is going to pass that along to the LED to give it the right brightness, essentially, based off of the position of the cursor. So hopefully that worked for some of you. So yeah, so it is a little challenging, especially because we have to deal with so many moving parts. So there's the Arduino code, there's the serial control application, then there's the P5 code as well. So we have to think about lots of different things when it comes to writing code for the computer and the applications on the computer, how we connect the Arduino to that code, using open sockets, web sockets, using the serial control application, and then also the code and how it's going to interact on the Arduino itself. So a lot of moving parts, a lot to think about. So yeah, but I still think it's worth exploring and playing around with. Another cool thing is that you could actually use this with like a live website hooked up to an Arduino that's hooked up to a server, and then anyone can control that Arduino on the website that's live. So there's a lot of really cool things that you could do that you can have interaction from anyone that has an internet connection to whatever application, whatever physical computing project you're building. So that's kind of cool. There's also, if you're interested in like playing around with like Internet of Things and the Arduino, there's the Arduino Cloud environment, which I actually haven't used, but it's pretty cool from what I can see. You can make like digital dashboards. There's an app that goes with it that you can control the Arduino through an app on your phone. So there's a lot of really cool stuff that you can do. So yeah, check out the Arduino Cloud IoT environment if you want to do stuff like that.